Okay, we're going to try to understand what the trigonometric ratios, alright, what it's talking about. For short, we like to call this the trig ratios. Many students find it difficult to pronounce, so trigonometric, or just for short, trig ratios. Now, the trig ratio is just another way of comparing the sides of a right angle triangle. Remember, the first method was by the Pythagoras theorem. But the only thing about trig ratio is that it's another way of comparing the size of the right angle triangle, but now it's going to be relative or with respect to the angle, right? The angle, let's call this angle theta, the acute angle. So the mnemonics for remembering these trig ratios is the popular and legendary SOHCAHTOA. So you must know your SOHCAHTOA. So SOHCAHTOA, we have that. So we're going to try to understand what the SOHCAHTOA entails. So you see that I'm putting the first initials in red because those are the trigonometric functions, right? The first one, that S there, stands for sine, the sine of an angle. For this right angle triangle here, you see the angle is theta, so the sine of theta. Okay, before we proceed, let's try to recall how to identify the sides of a right angle triangle. I said that the side that is facing this right angle is the hypotenuse, HYP for short. The side that's facing the angle is the opposite, while the other side is the adjacent. So we're saying that the sine of this angle theta, remember we're comparing this sides relative to the angle, which is theta. We're saying that the sine of the angle theta forms so now. That's the meaning of the first initial is the trig function, while the other ones, that's OH, is the sides of the right angle triangle. So we're saying that it is the opposite side, all right, divided by the hypotenuse. So opposite over hypotenuse. Remember, it's trig ratio. That means we're sharing the size. That's how big the opposite is to the hypotenuse, or how small the opposite is to the hypotenuse. Obviously, how small, because the opposite is the longer side. So I said that the sine of theta, all right, theta can be 30, 35, whatsoever, as the question will be, but that's what the sine of theta would be. The cosine of theta, please note that for short we like to write this sine as sin, kind of sin, but sine, while cosine is written as cos. So the cosine of theta is equal to, as you can see, the adjacent over hypotenuse. So the adjacent side divided by the what? Hypotenuse. While the tangent, okay, the tangent of theta is equal to, okay, let me write this tangent properly, just in case you don't know the spelling, so you can learn it. So tangent. So the tangent of theta, as you can see, is what? The opposite side over what? The adjacent side. So this is what you need to know. Now I just want to drop something. You see that this sine and this cosine, the only difference that you see is as though you just put CO as cosine. Now the reason for that is because that co there, that prefix co, is for complementary. Sine is complementary to cosine. What do I mean? The sine of an angle is complementary to the cosine of an angle. Remember, complementary angles are simply angles that sum up to what? 90 degrees. So sine is the complementary. That's why, for instance, sine 30 degrees will be equal to cos what? You're going to ask yourself, which angle will be added to 30 to make 90? Since sine is complementary to cos, you see it's 60. So sine 30 will always be equal to cos 60, because sine and cosine are complementary one to another. So that's what it is. Now, tangent is just the ratio of sine and cosine. Alright, so this tangent we are getting as opposite over adjacent. If you get the ratio of sine, what's the ratio of sine? Sine is opposite over hypotenuse, right? If you divide it by cosine, which is adjacent over hypotenuse, you're going to get tan. So tan is just the ratio of sine and cosine. Let's solve that. Opposite, this will be equal to opposite over hypotenuse. Change to times now. I have hypotenuse over adjacent. So hypotenuse will cancel hypotenuse. What do we have? Opposite of adjacent, which is the same thing here. So tangent is the ratio of sine and cosine. Okay, so if we know that, I think that's a good way to start. Now another thing I want you to take note of is the inverse of all these functions. The inverse of sine, what I mean by inverse, means 1 over sine theta. It has a name. So the inverse of sine, we call it the cosec theta. So 1 over sine is called cosec of theta. Alright, so 1 over sine is cosec theta. Why 1 over cos, that means the inverse of cos theta, is called secant theta. Do you get the point now? So if you have sine theta, you get the inverse, that means 1 over sine theta is going to give you what we call cosec theta. Why 1 over cos theta will give you what we call secant of theta. Why 1 over tan? So 1 over tan theta is equal to the cotangent of theta. In short, we just call it cot, C-O-T, cot theta. So note that actually this cosec is the short, the full is cosecant of theta. Alright, so again you see that sine and cosine, you see this one is cosecant, while this one is just secant. So that co also is there is for complementary. So just know that the sine and the cosine are complementary, and the tangent is the inverse of sine, the ratio of sine and cosine. So with this you can solve many questions. Now let me just differentiate Pythagoras theorem from the trig ratios, because you might wonder, okay, when do I use the trig ratio, when do I use Pythagoras theorem? So let's say we have a right angle triangle again. Okay, so that's a right angle triangle. Sorry for that line, but just leave it like that, just work with that. Okay, so since I've gotten rid of the line, I'll just draw another one. Okay, so this is our right angle triangle, so obviously this is the right angle there. Now, when do I use Pythagoras theorem? You use Pythagoras theorem if you know at least 2 sides. For Pythagoras theorem, you don't need to know this angle theta. Alright, you don't need to know it. You just need to have a side. Let's call this side A and call this side C. So you can find the side B using Pythagoras theorem. You're going to say that C squared will be equal to A squared plus B squared. So this is going to use Pythagoras theorem. And note, it only works in the right angle triangle. But for the trig ratios, how do I know that? When do I use the trig ratio? Use the trig ratio when you have, even if it's only one side and an angle. Right? So let me get rid of this C. Okay, so say I have A and I'm looking for B. I'll use the trig ratio to solve, and I know this angle theta. So this B rather, you see, is the opposite side, while A is the what? Adjacent side. So I'm going to say for my trig ratio, remember SOHCAHTOA, which of these trig ratio has the opposite side and the adjacent side? You see that that's TOA, right? So I'm going to use tangent. So I'm going to say tangent of theta will be equal to the opposite over the adjacent. So I cannot make the opposite the square root of the formula and then solve. Remember, I must know the value of theta. Maybe they will give me as 30, 35, as the case may be. So that's when to use this trig function instead of Pythagoras theorem.